Okay, we're going to be still working in lesson 3.6, but we're going to be taking a look today at just the or statements. Okay, so kind of this right here. So if I come up here and kind of review real quick, an or statement, I am going to the movies or I am going to dinner. So one or both of these might be true. They don't both necessarily have to be true. I can either go to the movies or I can go to dinner, and in reality we could do both if we had the time. So on an or statement, it is true for at least one of the inequalities. And so when we look at the shading, like for the and statements, we looked where do they overlap. For the ors, we're going to look at what has shading or what's been graphed. Okay, and whatever's got marking on it is an answer. So let's go ahead and flip over to the or section here. It's next page. All right, and so the or. Okay, example 1, write a compound inequality that represents the phrase, then graph. All real numbers that are less than 0 or greater than or equal to 5. Okay, so if I have less than 0, so like x is less than 0 or it's greater than or equal to -5, again, keep in mind that these two are like two different endings. Okay, so we're going to kind of repeat the first part here. We're going to have x and then greater than or equal to 5. Now, unlike the and statements, on these, we can't squish them together. We can't write them any other way. So this right here is going to be our final answer, okay? Now, it does ask us to graph. So when I look at a quick graph of this, so I have 0, 1, 2, 3, 4, 5. So I've got an open circle heading out this way, and I've got a closed circle heading out this way. Now, this is what a typical or statement will look like. They usually will shoot out opposite of each other. All right, and again, what's answers? Everything out here past 0 and everything out here past 5. Okay, those would be your answers. So nothing in the middle here will work. That is a no-go. Okay, all right, so let's try the next one. All real numbers that are less than or equal to 2.5. So again, x is less than or equal to 2.5. Or, so we put the word or in there. You have to have the word or in there. X is greater than 6. Again, note how we have got two different endings. Less than or equal to 2.5, greater than 6. Okay? So again, if we take a look at the number line, so 1, 2, 3, 4, 5, 6, put 2 here, 3. Okay, so at 2.5, I have a closed circle heading out, and at 6, I have an open circle heading out. And again, usually your or statement will look like that. All right, let's go to the next page. All right, solve each compound inequality, then graph the solution set, write your final answer in set builder notation, okay? All right, so let's zoom in here on the first one. So we're going to solve for A. Now notice how we've got two different inequalities that we're going to be working with. So we're going to solve this guy first, and then we'll go here and solve this guy. All right, so on this, we're going to subtract 1 from both sides and get A is less than 3. On the second guy here, we're going to add 1 to both sides and get A is greater than or equal to 4. So again, we're going to go ahead and graph 3, 4. So we have an open circle out, closed circle, shading out the other way. Okay, and again, this is what a typical or statement would look like. So now when I write my final answer, I pretty much already have my final answer ready to go here. I just need to stick the word or in between it. I need to put a line A out front, and then my set brackets for set builder notation. Okay, so this would be read as all values of A such that A is less than 3 or A is greater than or equal to 4. Okay, all right, let's go to the next one. All right, so on B, nice part about this guy is already solved for us. Yay, but this guy we need to go ahead and solve. So we'll start by subtracting the 2 off. So 4x is less than 8. And then we're going to divide by 4 and get x is less than 2. Okay, so now when I graph, I've got 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to start with the 2. I've got an open circle heading out this way. And then at 9, I've got a closed circle heading out in the same direction. So now on an and statement, we would have saw where do they overlap. We would have cut it off there, and this guy right here would be our answer, just the 2. But on an or statement, it's what has shading on it. So what has got a mark on it? Everything from the 9 over has a mark. So that would be your final grade here. Everything from 9 over is going to be an answer. And then you'll shade in. Okay, so now when you write your final answer, it'll just be x is less than or equal to 9. Put your line x out front and set brackets. Okay, so this right here would be my final graph with my final answer. Okay, all of this right here is just work to show me that from 9 over would be my final answer. All right, now the OR statement, let's go ahead and solve both of these. So on the first one, we're going to divide by 2. So x is less than -8. Again, I'm not dividing by a negative, so my sign does not flip. Now in this guy, I'm going to multiply both sides by -2, so that when I do that, I get x minus 4. Remember, top drops. Flip your sign because you multiplied by a negative, -14. So now I add 4, so x is greater than -10. All right, so now when I look at this guy, -8, -9, -10, I've got open circle heading this way. And then for my 10, I've got an open circle heading this way. So now ask yourself, what has shading on it? What's been marked? Well, in this case, the whole number line's got a mark. We've got a mark here, we've got double mark here, we got a mark here, you only need one. So this whole number line's going to end up being our answer. So I'm going to go ahead and just kind of highlight the whole number line here is going to be your answer. Now, if your whole number line's your answer, what do you think you're going to write? All reals. So those would be my 2 answers that I'm looking for. All right, next problem here. Write inequality, solve the problem. This includes graphing. Write your solution in set builder notation. The sum of a number and 3. All right, so if I'm doing sum, so if I'm doing sum, that means I'm going to be adding a number and 3. So I'm going to have x plus 3 is no more than 8. Okay, so if I'm no more than 8, 8 would be my biggest number. And then it says or, okay, so I'm going to put the word or in between. Repeat the front part again, because remember that you're basically getting just 2 endings here. Okay, so if you're looking here, you've got no more than 8 or is more than, more than 12. So you have 2 endings there. So now more than 12 would tell you 12 is the smallest number. Oh, come on, little guy. And it's going to be more than, so it can't be equal to. Okay? All right, so now we're going to solve and then graph. So I get x is less than or equal to 5. And then x, subtract the 3 off and get 9, so greater than 9. So now if I look at my grid here, from 5, 6, 7, 8, 9, I have a closed on 5 heading out. I have an open on 9 heading out. That looks like a pretty good OR statement to me. So I'm going to put the word OR in between, align X, set brackets, and there's my answer. All right, and on the last one here, write a compound inequality for the graph. Now the question always starts coming up now that we're doing ands and ors together is how do I know if this guy's an and or an or, okay? And the only piece of information we have to go on this is just look at the graph. If they're going out, so these are shooting out, that's an an or statement. If they were to overlap in the middle, that would be an and, okay? So in this case, it's an or statement. So I've got x less than -2 or x greater than or equal to 1. Now, it doesn't say anything about set builder. You could write set builder, just put a line x with set brackets if it says to do it. But since it didn't, the black part would be fine there. All right, and that concludes our notes for lesson 3-6.